In the smaller classes, you have learned that the sweet and bitter taste of food is due to acids and bases. So, if a person in your family is affected with indigestion due to overeating, what will you give him? Will you give vinegar, lemon juice, or a solution of baking soda? Definitely, you will give a solution of baking soda. This is because the indigestion is due to the presence of HCl in your stomach. That is due to the increased amount of HCl production in the stomach. So, in order to nullify this, we have to supply a base, which is here the solution of baking soda. In this chapter, we will be focusing more on acids, bases and their reaction. So, how can you identify whether a solution is acidic or basic? For that purpose, we generally use certain substances, and these substances are known as indicators. You have already learned about litmus paper in your smaller class. What is the color change in the case of litmus in the case of acids? Very good. In the case of acids turn blue litmus red. In the case of base, it turns red litmus blue. Likewise, there are several other indicators. One such indicator is phenolphthalein. What will be the color change in the case of phenolphthalein? Phenolphthalein is a colorless solution. In the presence of acidic solution, there will be no color change. But when a basic solution is added to phenolphthalein, or when phenolphthalein is added to a basic solution, the color turns pink. So, generally we can say that indicators are materials or substance which we use to identify between a base and an acid. There is another category of indicator which produce odor change in presence of basic media. Examples include onion, vanilla, etc. Now let's see how acids react with metal. For that purpose, we take 5 ml sulfuric acid in a test tube. Then add few pieces of zinc granules. What do you observe here? You can see that bubbles are formed on the surface of zinc granules. Now, we have to identify what is formed here. For that purpose, we collect the gas formed and pass it through a soap solution. When we pass it through a soap solution, gas bubbles are formed, and we place a burning candle near these bubbles. What can we see? Yeah, the candle burned with a pop sound, indicating the presence of hydrogen gas. So, we can conclude that acids react with metals, producing salt and hydrogen gas. So, acid plus metal giving salt plus hydrogen gas. Simply, in the example, we can say that zinc plus H2SO4 giving zinc sulfate is an SO4 plus H2. Now let's see how bases react with metals. For that purpose, take zinc granules in a test tube. Add 5 ml of sodium hydroxide to it. So you can see some bubbles are formed over the surface of zinc granules. In order to identify which gas is formed here, we have to pass it through the soap solution. So we can see that gas-filled bubbles are formed. In order to identify which gas is formed, we use a burning candle. When a burning candle is placed near this gas-filled bubble, we can see that it burns with a pop sound, indicating the presence of a hydrogen gas. So, as in the case of acids, bases also react with metal to give salt and hydrogen gas. So, we can conclude that base plus metal giving salt plus H2, that is hydrogen gas. Now let's see how metal carbonates and metal hydrogen carbonates reacts with acid. For this purpose, take sodium carbonate in test tube A and sodium hydrogen carbonate in test tube B. Add 5 ml dilute hydrochloric acid to both the test tubes. What do you observe? We can see that bubbles are formed in the gas. So, we have to identify which gas is formed here. For that purpose, we pass this gas formed through lime water, which is calcium hydroxide. When you pass the gas through the lime water, what do you observe? Yeah, it turns milky. So, this indicates the presence of carbon dioxide. Simply, we can say that metal carbonates and metal hydrogen carbonates reacts with acids producing carbon dioxide gas. Sodium carbonate Na2CO3 reacts with HCl, giving NaCl plus H2O plus CO2, and this CO2 escapes out as a gas. Next, we can see how the reaction goes for sodium hydrogen carbonate, which is a metal hydrogen carbonate. So, NaHCO3 plus HCl giving NaCl plus H2O plus CO2. So, generally, we can conclude that metal carbonates and metal hydrogen carbonates produce carbon dioxide when treated with acids. Now let's see how an acid and a base react with each other. For this, take 5 ml sodium hydroxide in a test tube. Add few drops of phenolphthalein to it. Is there any color change? Yes, the solution has become pink colored. So now add hydrochloric acid drop by drop. Is there any change in the color? Yes, the pink color begins to fade. So at a particular point, you can see that the color vanishes. So this is because the acid and base has reacted. So if we add few drops of sodium hydroxide again into the reaction mixture, we can see that the pink color is regained. So, we can say that acids react with bases to produce a salt and water. Salt is neither basic or acidic if it is from strong acid and a strong base. So, we can conclude that in a reaction in which acids and bases react to give salt and water is known as neutralization reaction. So, acid plus base giving salt plus water.